This is the key for the speed and velocity worksheet. Problem number 1 says a sprinter goes 100 meters in 9.8 seconds. What was her average speed? I made available to you the magic math triangle, and what you do is you look to see what the question is about. This one is about speed, and that's represented by the V in the triangle, and just pull that out. Now I'm going to write it in words instead of the symbol, but you could just put a V there if you wanted to. And what's left? If you take the V out of the triangle, you see a D over T. That means distance over time. So that's your equation. Now you just have to plug the values in. So the distance is 100 meters. Be sure to write the entire number, 100.0, and the unit of measurement, meters. The time is 9.80 seconds. And if you put that in your calculator, you'll get a value of 10.204 and then a few other digits that I am not displaying. Don't forget your units, the meters divided by seconds. That's not in your calculator, but it should be on your paper. Now this is not your final answer. This is an example of where we have to take into account that our measurements had a certain level of significance, a certain level of trustworthiness, and we now have to round our answer off to that same level of trustworthiness. So you don't have to do this on paper, but I'm going to make a table here that's got our values in it and the number of significant figures that correspond. So 100.0, that has a decimal in it, so all the zeros count. That has 4 significant figures. 9.80, that has a decimal in it, so that trailing 0 counts. That has 3 significant figures. Your answer cannot be better than your least significant measurement. So we have to round 10.204 off to 10.2, 3 significant figures, to match our least good measurement. Final answer, 10.2 meters per second. The answer is not 10.2 all by itself. It has to have a unit of measurement. Here's problem number 2. A car travels from Louisville to Indianapolis, a distance of 182 kilometers at an average speed of 91 kilometers per hour. How long did the trip take? How long did the trip take is time. So this question is about time. And if you pull time out of the triangle, you see distance over V. That V stands for speed. So it's distance divided by speed. If we plug in our values, we get 182 kilometers on top, 91 kilometers per hour on bottom. Now the numbers are pretty simple. 182 divided by 91 is 2. You may not know that kilometers divided by kilometers per hour equals hours, and you can just trust me on that. But anytime you have a denominator in the denominator, then you just see if you can cancel out the numerator with the numerator. And whatever's left, if it's in the denominator of a denominator, it becomes a numerator. So, long story, 2 is what your calculator will say. Hour is the unit of measurement that you'd write on paper. And so we have the correct units to measure time. Now this is not your final answer. This is a case of the opposite situation, where our calculator did not give us enough significant figures, because 182 has 3 significant figures, 91 has 2. Our answer cannot be better than 2 significant figures, but it also can't be worse. So the correct answer to this question is not 2 hours, it is 2.0. Your calculator will not supply that O unless you have it set in significant figure mode. Most people do not know how to do that, so you have to know how to do it with your brain. Correct answer, 2.0 hours is how long it takes you. In other words, this is not some average of about 2 hours. It is 2 hours. A car travels I-65 south with an average speed of 20 meters per second for 10 seconds. What is the car's displacement? Note that for direction, north equals positive and south equals negative. Why do we specify that? It's because displacement is a vector value. So if you're not doing vector arrows, you have to indicate direction some other way. In this case, we are going to use positive and negative. So for the purposes of this problem and for the majority of this class, if something is headed south, we're going to call that negative, and it says I-65 south. So it's not 20 meters per second, it's minus 20 meters per second. That is the velocity of this object. So if you pull the displacement, which is the d, out of the magic triangle, you see v beside t. That means velocity times time. And so we plug in our values. We should put in minus 20 meters per second times 10 seconds. The seconds in the denominator and the seconds in the numerator will cancel each other, leaving us with meters, and it's minus 200 meters. Let's do a check of significant figures. Both the minus 20 and the 10 have one significant figure, and the 200 has one significant figure, so we don't have to change anything. Since there's no decimal, those zeros are not significant. Final answer, there is a displacement of minus 200 meters, in other words, 200 meters to the south. The SR-71 spy plane, which incidentally still holds the record for fastest airplane, can go 3,500 kilometers per hour. If the continental USA is 4,800 kilometers across, how long would it take the SR-71 to cross the country at that speed? So anytime we're saying how long, then that is a time. That leaves the d over the v, so that's distance over speed. We don't have to worry about direction because this is speed and distance, not displacement and velocity. We substitute in our values, making sure to write our units, 4,800 kilometers over 3,500 kilometers per hour. And that gives us 1.371 and some other numbers that I've not written down. 1.371 hours. Now again, we have to consider this is a division problem. The values only have two significant figures each. So we must round it off to two significant figures. So the final answer, 1.371, should be rounded off to 1.4 hours. If you wanted to convert that to minutes or some other unit, that would be fine. So for example, that would be about 82 minutes. And that would be a correct answer as long as you use two significant figures. Question number 5 had two parts, so I'm going to break them into a part A and a part B. The Paris bullet train made a trip to southern France, a distance of 300 kilometers, in a time of 60 minutes. What average speed was the train going in kilometers per minute? You could argue that 300 kilometers is a displacement since it says that it's going to southern France, but seeing as it asks for speed, we don't need displacement, and so there is no need to designate the 300 as negative, because for distance, it doesn't matter which direction. So speed is the question. That leaves us with distance over time. Substitute in our values. Divide. You get 5 and then kilometers per minute. So that answers our first question. Now if we check our significant figures, we see that 360 both have 1. The zeros are not significant in this case because there is no decimal. They are trailing zeros and they are not actually measured. They are placeholders to show us where the decimal should go. So we'll stand on that answer of 5 kilometers per minute. Now for part B, you could have started from scratch and did the entire problem again, but I just made it into a conversion problem. So if it's going 5 kilometers per minute, how many kilometers per hour is that? I multiplied by the conversion factor of 60 minutes per hour. When you do that, you find out it goes 300 kilometers per hour. You probably could have puzzled that out If it goes 300 kilometers in a time of 60 minutes, that's 1 hour. So the answer is 300 kilometers per hour. Now, the 5 that we originally started the problem with, the way I did it, has one significant figure. The 60 minutes per 1 hour you might think has one significant figure, but that is actually a conversion factor that we can get as precise as we like. So it has an unlimited significance. We could say 60.000000, and we could say 1.00000, and it would be the same. So it has an unlimited significance. But it doesn't matter anyway, because the 5 has only one significant figure. So 300 also has one significant figure since it has no decimals. So this is the final answer, 300 kilometers per hour. An egg rolls off a table, and in spite of your lightning reflexes has gone splat on the floor. If the table is 1.20 meters tall and it took 0.495 seconds to hit, what was the average velocity of the egg? This again is asking us about velocity, and so the direction matters. So we are going to indicate up as being positive, down is going to be negative. And since this is falling down, that means its displacement of 1.2 meters should be negative 1.2 meters. So it's asking us about velocity. We'll pull the v out of the triangle. That leaves us with d over t, which is displacement over time. And as I said, displacement properly written should be minus 1.20 to indicate it's falling down, divided by the time gives you minus 2.42, repeating. If we check the number of significant figures, we find that both values used to get the answer have 3 significant figures. We should round our answer off to 3 significant figures. Final answer, minus 2.42 meters per second. A football is thrown a horizontal distance of 21 meters. That's a long way, by the way. So we're talking about maybe a professional football player here. At a speed of 24 meters per second. How long did it take to reach the receiver after it is thrown? How long is time? What's left in the triangle is d over v, so that's distance divided by speed. Substitute in your values. Make sure you put the right numbers in the right place. Write their units beside them, and that will help. It's not 21, it's 21 meters. It's not 24, it's 24 meters per second. The final answer is going to be less than 1. In fact, it's 0.875, and the meters cancel out, leaving you with seconds. If we check the significant figures, though, we see that our values have only 2 significant figures each. We need to round that 0.875 off. Since there's a 5 at the end, we're going to round that 7 up. Final answer, 0.88 seconds. A man is timing a runner on a track. At the 50.0 meter mark, he starts his stopwatch. At the 100 meter mark, he shows a time of 6.67 seconds. What was the runner's average speed? Now, this seems like a straightforward problem, a speed problem. It is speed equals distance over time. But you have to realize that in this case, we are given 2 distances. So what this formula properly should show is a change in distance. So in other words, it is 100 meters minus 50 meters. He started it at the 50 meter mark. That's the initial time start mark, and the 100 meter is the final. So final minus initial is 50 meters divided by 6.67 seconds gives 7.496 and some more numbers meters per second. Now there are some decimals in the values, the 50.0 and the 100.0. When you subtract, you have to keep that decimal, so it's 50.0 in the numerator, not shown. And so the 50.0 has 3 significant figures. 6.67 has 3 significant figures, so our answer has to be rounded off. 7.496, the 6 makes us round the 9 up to 0, but that makes us round the 4 up to 5. So it's not 7.5, it's 7.50, because you have to have 3 significant figures. So that's our final problem. If you have any questions about any of these problems on this worksheet, please contact Dr. Kemp.